Hi everybody, this is lesson 3, writing products as sums and sums as products. Okay, that might sound a little confusing, but our essential question here is how can we prove the distributive property using tape diagrams and rectangular arrays? So tape diagrams are something that you should be familiar with. If not, I'll go ahead and explain it as we go. And then tape diagrams are going to take a little bit of more depth in this lesson, and we're going to use them for something called rectangular arrays. Okay, for the opening exercise, we're going to solve this problem using a tape diagram. A sum of money, go ahead and underline that. We know that a sum of money was shared between George and Brian in a ratio of 3 to 4. Okay, George's name came first and Brian's name came second, so that'll be important when we do this. If the sum of money was $56, how much did George get? Okay, we know that it's 3 to 4, and altogether it's $56. So a tape diagram can easily be split into 7 pieces, 1, 2, 3, 4, 5, and then the last line splits it into 7 pieces. And we also know that altogether it's going to be $56. Okay, and then it's 3 to 4 for George and Brian, so 3 for George and 4 for Brian. Okay, so how much did George get? Well, we know that George gets 3 of these boxes and Brian gets 4 of them, and altogether it's $56. So hopefully you figured out by now that I can do 56 divided by 7, and that will tell me how much goes into each box. So we can write it like this. All right, and then very easily, George is 8 times 3, and Brian, even though they don't ask it, would be 8 times 4. So $24 for George and $32 for Brian. And you can double check that by adding them together, and you know that 24 plus 32 equals 56. What we just did was we took the 3 plus 4 and multiplied it by a number to get 56. So what number was that? Well, we figured out by working backwards that that was 8. So there's one way that you can kind of see the distributive property in action. We know that 3 times a number plus 4 times a number gave us 56. So 7 of those numbers gave us 56, or if I divide by 7, I get that x is equal to 8. And that's the same thing that we did up above when we made the tape diagram. So hopefully that's a good refresher for you. A tape diagram is really just a visual to help you kind of see a problem more visually and get your thoughts onto paper. So it's a good model for you to use. Okay, we're going to do some simple ones now. We're going to use 3 plus 2 using a tape diagram. Well, you already know everything in this problem. It's just 3 plus 2. So I know that I have 5 altogether. 1, 2, 3, 4, 5. I'm actually going to move this up so we have some room. And this is 3, and this is 2. Okay, couldn't be a whole lot simpler than that. The next one says x plus 2. I don't know how big to make that one. I don't want to make it the same size as the 2. In fact, when I make the 2, I can make 2 equal sized boxes here. Like say how those both equal 1. So together that would be 2. And then whatever's left, I can call that x. So we're going to call that x. You can put the x inside or on the outside. It doesn't matter. In fact, you could even write this as like 1 and 1, so you see that that's what makes 2. Okay, now we're going to make a rectangular array for 3 times 3 plus 2. What that means is we're going to do 3 rows of 3 plus 2. 3 rows of 3 plus 2. So we're going to go back to the one up above, the first one in example 1, and we've got 1 row, 2 rows, and 3 rows, and each one of those is going to have 2, 3, Made it a little too big, but that's okay. That's all right. You just split it how you see best. So this would be 3 on the bottom. This would be 2 across the bottom. And then here, this is 3 rows. So I have 3 rows of 3 plus 2. Now, if I simplify 3 times 3 plus 2 in parentheses, that's 3 times 5. And that's exactly what we made over here. Okay, that's 3 times 5, which is 15. So you notice that there's 15 boxes represented. Okay, so that's kind of combining the tape diagrams. More than one would make an array. Now what we're going to do, the last one here, it looks just like that, except instead of this 3, like there's 3 here, we don't know how many. So if you go to the top of page 18, now we still know it's going to have 3 rows. So let's do that. Let's make that side. Okay, so we know it's going to be 1, 2, 3 rows. And we know that on the bottom, it's going to have X, which I don't know how far that is, but I do know that these ones right here would be 2. So if you kind of look, I'm going to go back to the highlighter here so you can kind of see this right here is X plus 2. Because if you go back to page 17, if you look real quick, you can see that that's equal to that row, that X plus 2. And then if you notice, we basically have 3 of those. See, here's another one, and here's another one. So that's why it's 3, because there's 3 rows of X plus 2. Okay, now what we can do is we can say we have how many X's? 1, 2, 3, so that's 3X. And then how many numbers do we have? We have 1, 2, 3, 4, 5, 6. So 3x plus 6. And if you remember from the distributive property, 3 times x, which would be 3x, and then 3 times 2, which gives me 6. So this is just kind of a visual for you to see where that comes from. Okay, in exercise 1, we're going to come up with the areas when we know the numbers. So this one is saying 11, and I'm going to multiply that by 16, and I'm going to multiply it by 5. So I can write it like this using the distributive property. And then inside here, I can do 11 times 16, which is 176. And then I can do 11 times 5, which is 55. Okay, and you can kind of think of that as area. See how 11 times 16 gives me the area of that rectangle? And then I'll change colors so that you can see 11 times 5 gives me the area of that rectangle. So you can multiply 11 times 6 is 176. Or sorry, 11 times 16 is 176. And then you can do 11 times 5, which is 55. So that's one way that you can get it. Or you can just do 11 times 16 plus 5, which if you know the numbers, that would be 21, and then you can do 11 times 21. Okay, if you work it off to the side, you can use your calculator. And it looks like 231 is our answer. And there you go. Okay, so you get the same thing whichever way you try it. Okay, the question is, what would the numerical expression look like? There's a little blank there. Go ahead and add that question in. What would the numerical expression look like? And that would just be what we had here, the 11 on the outside and then 16 plus 5 on the inside, which equals 11 times 16 plus 11 times 5. Okay, so there's a little more distributive property in action. All right, for example 2, we're going to go through these kind of quickly. We're just going to show 3 separate x plus y's for the first example. So I don't know how big x and y are, but we kind of want to make them different sizes just so that I can see. So even though I don't know which one is bigger, I'm just going to make the x bigger just so we can see a difference. So there's one x plus y, there's another x plus y, and here's one more x plus y. So that would be the first example. For the second example, it's having me put all 3 x's together, then all 3 y's together. So the first one will look kind of like this with the longer x's. So here's 3 x's. And then here's another one with 3 y's. I could do 3x plus 3y as rows, so kind of like the last one we did where we made this 3 and this was y. Sorry, we'll go like that. There we go. So each y. I did that one first, but we're going to move it over just because the x's were supposed to be first. Sorry about that. And then the x's, those ones are longer, but there's still going to be 3 of them. So here's the 3, and here's the x. Okay, the last one is if we kind of put this together and make one rectangular array, because the way that they are now all chopped up is a little harder to see, but if we totally simplify it, we can see that there's going to be 3 rows. One, two, three. And then we know that the x was a little bigger, so we're going to put the x here, and we're going to put the y there. Okay, so that would be 3 parentheses x plus y. So this is just a visual for you to see where all these numbers are coming from. If you were to multiply 3 times x, that would be the area there, which is 3x. And then in this one, 3 times y would be 3y. So 3x plus 3y, and that's actually what all of these are equal to. If you take them apart and look at them, you see that they all have 3 x's and 3 y's. Each one of these, for examples, has 3 x's and 3 y's. Okay, so it's just a way to visualize them and see their similarities. Okay, how this works with what we're going to do in class is right here in example 3. It says to find an equivalent expression by modeling with a rectangular array and apply the distributive property to 5 parentheses 8x plus 3. So this will be the one that I kind of have you refer back to in class so that you can see the area in action. So it's 5 times 8x plus 3. So I know that I want to make it 5 tall. So 1 row, 2 rows, 3 rows, 4 rows, 5 rows. Okay, and then this one is going to be 8x, and then this one right here is going to be 3. I could split it into 3, but you just need to see it like this, because what we're going to do is we're going to see this as the area. This is 5 times 8x to get the area that I have in red, and then it's 5 times 3 to get the area in blue. So for red, let's write it like this. 5 times 8x, and then in blue, 5 times 3. And now if I simplify both of those, I get 40x, and I get 15. So this is equal to 40x plus 15. And that's what happens when you distribute 5 times 8x and 5 times 3. Okay, we're going to go ahead and stop right there. We're going to do some of the division ones together in class, and then we'll continue on in class doing some more of these rectangular arrays. And don't forget that you can ask any questions when we work on it in class. So no stressing. It's basically taking this expression 8x plus 3, and I'm multiplying each term by the outside number, in this case 5. So 8x times 5, and then 3 times 5. And that's where I get 40x and 15. So again, we're going to do the lesson 3 independent practice in class, and you'll be able to ask all your questions then. Okay, see you later.